Okay, so in this video we're going to be going through a GCSE Mathematics foundation paper. This is a paper which students at around the age of 16 sit for their maths exams in school. And what I'm going to do is just go through this and give you a feel for what it's like. Now, when I'm going through this, I assume that you guys all have an understanding of maths in terms of, going to school and knowing the topics. So I'm not going to go in detail through every single question and sort of the topic itself. I'm just going to go through and see if I can sort of answer the questions. Okay, let's get into it. So the first question asks us to figure out what 2 to the power 4 is. Well, what you should know is that 2 to the 4 basically means 2 times 2 times 2 times 2, where we have 4 2's. And if you do that, that's the same as 4 times 4, which gives you 16. The next one, it says, write 7.26451 correct to 3 decimal places. Well, if we have a look at the number, this is your first decimal point, this is your second, and this is your third. So that means we need to round this one. And since the number to the right is 5, that means we round this number up, so that it ends up being 7.265 to 3 decimal places. Okay, so we write that here. Okay. Next one, it says simplify this expression. A simplifying, remember when it comes to algebra, just means writing everything together, so all the numbers together, so 7 times the 8, which gives you 56. And then E times the F, which you can just write as EF. Okay. Next one, it says solve for X. So what we need to do is move this 5 over to the other side of the equation. And if we do that, it turns into a multiply. So we get if X over 5 is equal to 2.5, then we can say that X is equal to 5 times 2.5. And if you do that, well, 5 times 2 is 10, and then 5 times a half is 2.5. So adding that together, we get 12.5. Next one, write 4/5 as a percentage. Well, you should know that 1/5 is 20%, so 4/5 is 80%. But another way, again, turning fractions into percentage, is just multiplying by 100. So if you get your fraction, multiply it by 100, that should turn it. Again, when multiplying, you multiply side to side, so you get 400 over 5. And then if you do that, do the division, then you get 80. Okay. Next one, 60% of 70. Again, these questions I think are all non-calculator. And let me just double check. Yeah, non-calculator. So you will have to have these skills. So 60% can be written as a fraction as 60 over 100. Then timesing that by 70 should give us our answer. 6 times 7 is 42. 42, and then adding the 2 zeros on. And then on the bottom we have 100. From these multiplying horizontally, and if we do this, we can cancel off some zeros, so we get 42 over 1, which is 42. Next one, Sammy spins a fair 4-sided spinner. What's the probability that it will land on B? Well, remember, probability is what you want over the total. This is roughly how I remember it. So what we want is B's, and as you can see we have 2 B's, and in total there's 4 things. And if you were to simplify that, you get 1/2. So you'd have to put a cross there. What's the probability that it will land on F? Well, that will be 0, and the reason is that F doesn't actually exist. It's not an option on our spinner, so there's 0 chance of it happening. Okay, next one, We have Fahima buys 2 packets of bread rolls costing this much for each packet, 1 bottle of ketchup costing £1.60, and 3 packets of sausages. It then says that Fahima pays with a £10 note. She gets 30p change. She works out that sausages cost this much, 1 pack. And we need to show if she's right. So we can figure out the cost separately. So for bread rolls, the cost would be, well, is 2 packets. And for each one is £1.50, so it's this much, £3. For ketchup, the cost is £1.60, and then 3 packs of sausages. Okay, so if we add up the total so far, so sausages is equal to 3 times if we now add up what we have, so we have £3 plus £1.60, that's £4.60. So we know that £4.60 plus the price of 3 lots of our packets, which I'll call P, would be the total amount that she bought. And if she pays with a £10 note and gets 30p change, then that means in total the amount was £9.70, right? The difference between what she used to pay with and the amount that she gets back. So we know that it's this. So now what we can do is just solve this equation to find out what P is, which is what I've called the price of 1 sausage pack, I should have said here. So doing that, what we end up getting is we get 3p equals, well, taking away 4, you get £5.10, I think, if you do that. Okay, and then to get the p, we can do this division. So we do £5.10 divided by 3. And if we do that, let's do it now. We'll do a little bit of working out. So 510 divided by 3. So 3 goes into 5 one time, remainder 2. 3 goes into 21, and it goes 7 times, and 0 carried over. So we get £1.70. So as we see, the answer that we get for 1 pack is different from what Fahima says, which is £2.30. We got £1.70. So the answer, so therefore no, Fahima is wrong, since we calculated that 1 pack is £1.70, like that. So the answer is no. Next one, we have to do multiplying fractions. So if you have fractions and you multiply them, you always multiply horizontally. So doing that, we get 15 on the top, and then 4 times 8 would give us 32. And so I think we could leave it as that, 15 over 32. Next one, we're subtracting fractions, so we have to make a common denominator. If we make a common denominator, let's pick 12. So we can have 12 on both, so 12 on both. And then we could say the first fraction, what do we need to multiply the 3 on the bottom to make it a 12? Well, that would be 4. And then what would we have to multiply the second fraction by, the 4, to get 12, which would be 3. And then do the same to the top and bottom now. So we can say that 4 times 2 would give us 8. And then 3 times 1 will give us 3. And now we can just subtract the tops, which will give us 5 over 12. Okay. One done. Okay, another problem solving one. So Sean works for a company. His normal rate of pay is £12 per hour. When he works more than 8 hours, he's paid overtime for every hour that he works more. His rate of overtime pay is 1 1/4 times his normal rate of pay for 1 hour. And he works for 10 hours on Monday. Work out the total amount that he earns. Well, let's firstly figure out what his overtime pay is. So overtime pay, which is what they tell us in this sort of line here, is 1 1/4 times his normal rate. Well, his normal rate is £12. So if we do that, we get £12 and we multiply it by 1 1/4, right? So a quarter of 12 is 3, and then we add that on to 12, which will give us £15 is his overtime pay per hour. And so for the first 8 hours, so if we think about this here as being his work day, so this is Sean's work day, then it looks something like this, where this is the first 8 hours of normal pay, and then since he works 10 hours, we have an extra 2 hours of overtime pay. So totaling up, so the total for the day for Monday would be equal to his normal work pay, which is normal rate, which is £12 times the number of hours, so it's 8 hours times by £12 per hour, and then we add to that the overtime pay, so he works an extra 2 hours with a rate of 15. So if we do this now, so 8 times 12 I think is 96, and then 2 times 15 is 30. So now adding these two things up gives us 126, and then again this is in units of pounds, so that's the total that he makes. Cool. So now a farmer has 20 boxes of eggs. There are 6 eggs in each box. Write it as a ratio the number of eggs in 2 boxes to the total number of eggs. So what we do is number of eggs in 2 boxes, and we write that as a ratio of the total to the total number of eggs. Okay, so if we do that, then we need to know what the number of eggs in 2 boxes are. If there's 6 eggs in each box, then in one there should be 12. Oh, sorry, in one there should be 6, and then in 2 there should be 12. And then the total number of eggs, well, we know that we have 20 boxes, and each one has 6, so it would be 20 times 6, which is 120. And then again, if we simplify it, so we simplify the ratio, so 12 goes into both, goes in 1 time, and it goes in here 10 times, then our final ratio would be 1 to 10. And again, it's important in ratios that you write the ratio in the order that it tells you. So it says the number of eggs in 2 boxes to the number of total eggs, so it has to be in this format. If you did it the other way around like this, there's a chance you'd get it wrong. Okay, so next one. A sequence of patterns is made from circles and squares. How many tiles are needed to make pattern number 6? So what we need to look at now is the relation between the squares and the pattern number. So in pattern number 1 we have 1 square, in pattern number 2 we have 4 squares, in pattern number 3 we have 9 squares, and if you'd notice, the number of squares is going up in terms of squared numbers. So that must mean that the first pattern first would have 1 square, the second would have 4 squares, third 9 squares, so it's going up in square numbers. So this is I'll write that down, so square numbers. So if you want the 6th pattern, so that would have 6 squared, which is 36 squares. So you just square it. So how many circular tiles are needed to make pattern number 20? This is exactly the same thing. However, this time we need to link the circles to the pattern numbers rather than the squares. So in the first, we have 4 circles. In the second, we have 8. Again, just make sure you count carefully. Third, we have 3, 3, 3, 3, 12. And what you can see is that, notice, they're going up by a common difference. So it's going up by 4, then another 4, and then it keeps going up in 4s. So what we can do is write the nth term for this pattern number. So firstly, we take the difference, which is 4, and multiply it by n, and that's our trial sequence. And then put 1, we put 2, we put 3 in there and see what we get. And if you do that, you notice it lines up exactly with what we have in our pattern. There's no offset. So our sequence or nth term for this particular sequence is for n, and therefore in pattern number 20 we would have, you just put in 20 where n is. So this is the nth term. 20th term therefore would be equal to 4 times by 20, which would be 80, right? Just by putting it into the nth term. So then Derek says when the pattern number is odd, an odd number of square tiles is needed to make the pattern. Is Derek right? Well, when the pattern number is odd, let's look back to our square tiles. And if you look, pattern number is odd. And so our square tiles is odd. Same with here. This third term is odd. And the squares is also odd. And so by looking at it, it sort of makes sense, right? So what we notice is that it's an odd term in every single pattern number that's odd. And so the answer can be yes, right? So yes, Derek is right, since what we're doing is, remember, the link between the terms and the square tiles is sort of the squared numbers. So if we only ever pick square odd terms, then to get our number of squares we have to square it. So it's like saying an odd number times an odd number. So yes, Derek is right, since odd numbers times odd numbers are always odd. Okay, so what we're doing is the link between, so pattern number squared is equal to square tile number. Therefore, if we choose an odd pattern number, then this value, whatever it is odd number squared, and that's what square is, which means that square must be odd, since this is odd times odd. Okay, next one. So there are only 7 blue pens, 4 green pens, 6 red pens in a box. 1 is taken at random from the box. Write down the probability. Again, we wrote down earlier, so probability is what you want. You want over the total. So in this case, what we want is the number of blue pens. And as we can see, we have 7 blue pens. And the total number of pens that we have in total would be 7 plus 4 plus 6, which gives us 17. So the answer is 7 over 17. Next one, the diagram shows a tree and a man. The man is of average height. The tree and the man are drawn to the same scale. Write down an estimate for the real height in meters of the man. So I think the way to do this is I think you just need to know roughly what an average man's height is. And so this you sort of need to know. So in my head, the average height of a man, at least in the UK, is roughly 1.8 meters, which is the same as 180 centimeters. So I'd put 180, and in reality, again, for the questions like these, when it's estimates, sometimes there's a range in the solution, so don't worry if you're a little bit off or above or below this. You should get it right if you write something reasonable. Okay, so now what we can do is the same thing. So find an estimate for the real height in meters of the tree. Well, to do this, we have to use, so we were told that the diagram is to scale. So diagram is to same scale. Therefore, find how many times bigger the tree is to the man. So we basically can just find the scale factor. So the man is basically like roughly this tall, and the tree is roughly around this tall. And now because I don't have a ruler, I'm just going to roughly estimate by sort of using my finger and sort of roughly trying to judge. But in my head, that would basically be around 3 to 4. It looks roughly 3 to 4 times bigger. So we could say tree looks roughly 3/4 times bigger than man. And if this is the case, and we know that the man is roughly 1.8 meters tall, then what we can do is I'm going to use the upper bound for this. Again, I might be wrong. It might be slightly bigger, let's just say 5, but I'm just going to say, let's just say 4. So if he's 4 times bigger, then tree height would be sort of this scale factor times by height of man, right? Because we know that the drawing is to scale, which would be roughly 4 times 1.8. And so 4 times 8, or 4 times 0.8 is 3.2, and then 4 times 1 is 4. So I'd roughly get around 7.2. Now this might be wrong, so I'm going to make sure. So check yourself by using a ruler. But generally, the general method that I've spoken about is what you should do. You might find the scale factor slightly bigger. So now, Year 9 students from a school choose one particular language. So what I need to do is draw an accurate pie chart to represent this. Well, what we can do is firstly find the total. So the total, figure that out. And so the total would be 56 plus 40, which is 96. And then that plus 24, which would give 120. So we know all children must fill, in this study, must fill up the pie chart. So 120 students must equal the full circle, which is 360 degrees. So that must mean that for each student, so for one student, that would be 360 over 120 degrees. And if we simplify that by cancelling out, you'd get that that's around 3 degrees. So that means one student takes up 3 degrees. So what we can do is figure out the number of degrees that each of them take up. So here in the first one, French, if we have 56, then 56 times 3, well, 3 times 6 is 18. 3 times 50 is 150. So 150 plus 18 would give us 168 degrees. So if we could say the angle will be 168 degrees. Then if we have 40, 3 times 40 is 120 degrees. And then 3 degrees for each student times the last one, which is 24 of them. That would be 3 times 4 is 12. 3 times 20 is 60. So 60 plus 12 is 72. And now it's a case of, again, accurately drawing this out. Now, I haven't got a protractor on me, but hopefully if you do, you'd be able to measure it out accurately. So let's roughly get things right. So we know that if we continue down here all the way to the bottom like that, we would get what I would say would be 180 because it's a straight line. So you were to continue down here. But since French is slightly under 180, temporarily I would just roughly do something like this. So let's switch this. Let's go here. Something slightly like this. Again, this is definitely probably a little bit off. So this is what I would say would be the French, and I'll just write the angle so that even if it's a bit wrong, at least people know what I'm talking about. Then we'll do 120, which would roughly be something like this. Again, because here from around here to here, you know that this basically is 90, right? So this angle here would be a 90-degree angle. So in order to get 120, we'd have to do something slightly bigger. In fact, an extra third of that region. So what we'll do is we'll write this one as Spanish, and this is 120. And then this one has to be German, which is around 72. So again, this isn't fully accurate, but yeah, definitely use a protractor when you're doing this. So now it says that a different school do the same thing, and then we have this. And it says the pie chart shows that French was chosen by more Year 9 students at low read. Now, what you do have is in this pie chart, for this school, the French region is a lot bigger, or it looks at least a lot bigger than the French region in our initial thing. But from that alone, can you judge whether there are, more or less students that studied French? Well, the actual answer is no. And the reason is because even though that you know that the region is bigger, you don't know what that means in terms of the number of students. Even though the region is really big, like this region is huge, it might only be that in this school, there's only like 30 people in total. So this fraction, larger fraction of only 30 people still won't be that much. And then in the end, this number, even though the proportion was smaller, would have actually more people. Like here they have over 50. So the answer is no. So this person, Shamina, is not right. Okay, and then we can say the reason for this is that you have no data, right? So no actual data to tell you about the number of students. So if you have no actual data, a pie chart is only there to roughly represent the data and show you like the proportions that are in each category. It doesn't actually, without any further information, tell you anything about the number of things. Of course, unless it literally said it on it, but you know, the general idea is not for that. Next one. So we have a right angle triangle and a rectangle, and it says to us a link between the areas of both, work out the width. So we have to use this. So what I would say is whenever you see some things like this, like a relation that they tell you about, what you need to do is use it. So use it. So area of triangle, we know is a half base times the height, which in our case would be a half times 8 times 9. So that would be 4 times 9, which is 36. And again, units would be centimeters squared. Area of rectangle would be the base times the height, which in our case would be base 16 times the width. I'll call the width W, so 16W, and again units centimeters squared. So now we could use this relation. So area of rectangle will be equal to 6 times area of triangle, and since we know that, since we know the areas, we can just put them in. So area of our rectangle, I'll leave out units as 16W. Area of our triangle is 36, so 6 times 36, like this. So now calculating it, 6 times 6 is 36, 6 times 30 is 180, so adding them together would be 216, I think, 16W. I think that's it. Okay, so now to find what W is, we just move the 16 to the other side, so it's 216 over 16, and if we do that, we could just do some rough division. 216 over 16, put decimal here. So 16 into 21 goes 1 time, and the remainder is 5. And 16 into 56, well, I think it can go 3 times, right? Because 3 times it is 48. So it can go 3 times, and we'll carry over the decimal, but the remainder is 8, right? 8. And then 16 into 80, well, that goes 5 times. Because if we do 16 times 5, that gives us 80. And then, of course, there's nothing left over, so that's our answer. So the width would be 13.5, and then you have to put the units of centimeters. Okay, good. Next one, work out the value of V. So again, if you guys don't know, this is actually an equation in physics. All you need to do here is substitute it in, but basically this is known as one of the Suvat equations, so one of the Suvat equations. And what it's used for is calculating motions of particles in scenarios where the acceleration is a constant. But anyway, all we need to do is plug things in. So V is equal to U plus AT. Plugging everything in, U is 1. I'll put brackets when I'm substituting. A is -3 and T is a half. So it's a 1, and then plus -3 times a half is -1.5. And 1 minus 1.5 would be -1/2. Right? And again, if you can't do this in one step, I'd recommend doing the longer method where you sort of make a common denominator, because we're sort of subtracting fractions from numbers, and then solve it that way. Okay, this one, 5 tins of soup have a total weight of 1,750 grams. 4 tins and then 3 packs of soup have a weight of 1,490. Work out the total weight of 3 tins and 2 packets of soup. Well, from the first one, since we know 5 tins is equal to 1,750 grams, then we can figure out what 1 tin is, right? So actually I'll do that up here. So from that, we know that 1 tin would be 1,750 divided by 5, and that will be in grams. So if we do that, 5 into 17 goes 3 times, remainder 2. Then 5 into 25 goes 5 times, and then sort of we carry over the 0, so it's 350 grams. That's what 1 tin is, right? So now that we know that 1 tin is that much, we could put that useful information into this relation that we have here, and then use it to solve what the soups are. So if 4 tins is what we want, and we know 1 tin, so 4 tins would be equal to 4 times 350. Now if we do that, 4 times 50 is 200. 4 times 300 is 1,200. So 1,200 plus 200 is 1,400. And again, the units are grams. And so we know that weight. And then, so if we know that, then we could put this into our initial equation. So we know that 4 tins plus 3 packs of soup. So what I'll do now is let S be packs of soup. So we know that the 4 tins, which is 1,400, plus 3 packs of soup, so I'll say 3S equals 149T, like that. So that's what we are told in the second line. Using this, we can rearrange the equation. So we get 3S is equal to 90, and then S would be equal to 30, and then that's in grams. So now we know that the weight of the pack of soup. So actually I should have sent that pack of soups. Weight is 30 grams. Then we can now calculate what we want. So total weight of 3 tins plus 2 packs would be equal to 3 tins would be 3 times 350, right? Because each one is 350, and add to that 2 packs, and each one is 30. So doing this, 3 times 50 is 150. So 150 plus 3 times 300, which is 900, gives us 1,050, plus, and then 2 times 30 would be 60. Adding those together gives you 1,110 grams. Okay, so next one, this person has a garden in the shape of a circle with this radius. It's going to so you need something to cover the garden with grass seeds to make the lawn. Grass seeds are sold in boxes. Each box will cover 46 meters squared. It's given us an area. This person wants to cover all the garden with grass seeds. Okay, work out an estimate for the number of boxes of grass seeds Balina will need. So the if we know the radius of the circle, firstly, because everything's dealing with area, because we need to cover the lawn. We need to cover the garden lawn. We need to cover the garden with grass seeds to make the lawn. Then what we can do is we know that the area of a circle is equal to pi r squared, implying that area of garden, which is in the form of a circle, would be pi times the radius of the garden, which is 10 all squared. And I'm just going to label area of garden with A and then a little g. So A and then a little g, and that's 10 times 10 is 100 pi. Okay, and then units would be in meters squared. So then each box of grass seeds will cover 46 meters squared, right? but we have a total of 100 pi meters squared. And if we're trying to estimate, so to estimate, what we can say is make pi approximately 3. So we know pi is 3.14 and it sort of continues forever, but for an approximation we could just assume that it's 3. And if we do that, then area of garden would be 3 times 100, which is 300 meters squared. Okay, so we do that. Then what we can also do is to make things sort of approximate, we can then also round, right, we could round the sort of meters squared covered by the garden. So let's just say each grass seed. So to estimate again, we say, let's just say 46 meters squared, which is what it covers, is roughly equal to 50 meters squared. And then to figure out the number of boxes, well, that would just be equal to area of garden divided by the area of one box. Which in our case would be approximately 300 over 50, which is roughly 6. So our answer is 6. So again, with estimates, like I said, there'll probably be a range for the answer, so it doesn't matter if you've got something slightly different or you made some slightly different approximations. I sort of just made the approximations which make sort of the question as easy as possible in terms of the division, especially since this exam is a non-calculator exam. So now it asks us, is your estimate for part A an underestimate or overestimate? Well, what we need to do is to figure out underestimate or overestimate, we need to understand where we sort of made the approximation. Well, notice here, we made the approximation in pi and in the area that the grass seeds cover. Now, notice, because both of these estimates in the end have an impact on sort of the area, right, of the garden and the grass seeds, the area that it covers, then we need to see which one sort of has the majority net effect, and therefore that will tell us. So in our answer we had to divide them, and notice our area of our garden, we actually made it smaller, because in fact the real value of pi is 3.1415 and ... So by removing all this and just using the 3, we've made our answer smaller. And since this pi was being multiplied by 100, that is actually a big difference, because even though that it was only a small difference, actually a difference of 0.14, let's just say, then when you multiply that by 100, that is then amplified so that the net difference is 14 meters squared roughly, right? Sort of made that that amount of difference. Whereas here, to estimate the grass seeds, yeah, we also made this one bigger, but we only made it bigger by around 4 meters squared. So you made this one smaller by 14, and then you made this one bigger by 4. So the net effect, by making this smaller than what it is and making this bigger than what it is, the net effect has made the overall fraction really a lot smaller than what it was. And the reason is when you have a fraction, if you have the top of the fraction and you make it smaller, and then you make the bottom as big as possible, then as a net effect, the whole fraction becomes a lot smaller. So the answer is an underestimate, since we rounded pi down and the area covered by the grass seeds up. Okay, good. So next one, solve this. Well, I would write it out. Then when you have something like this, you could expand this out. So 4x minus 20. Move the 20 over to the other side. And then divide by 4. And if we do that, we get x is equal to 9.5. So write all the possible values for t given this. Well, if this is what we have, then t is bigger than 3 and t has to be an integer. So the next integer up from minus 3 is minus 2. So if this is 2 minus 3, we have minus 2, minus 1, 0, 1, and then 2. Well, it could only be this one, this one, this one, this one, and this one, because it cannot be minus 3 because it has to be bigger, and it can be 2, so it's those. So write down all the possible values. So t can be minus 2, minus 1, 0, 1, and 2. Okay. Okay, so Asmal is paid $1,500 per month. He is going to get 3% increase. Work out how much money Asmal will be paid after the increase. So what we can do is you can find 3%, which is 3 over 100 of 1,500. And by finding that, we get 15 times 3 is 45. 500 over 100. Cancel the zeros. So we get 45 over 1, which is 45. So he would be paid an extra £45. If he's paid an extra £45, then we add that on to our original amount, which would be, so new amount paid would be equal to £45 extra plus his original, which will be that per month. Okay, next one, the scatter graph shows maximum temperature, number of hours of sunshine. Cool. So one of the points is an outlier. Write down the coordinates. Now an outlier is just a point which doesn't follow the trend. Now if we have a look at this graph, then can you see that generally most of the points lie around this line, but this point doesn't. So this is what we call an outlier. So then all we need to do is write down the coordinates. So just making sure that you do that correctly. I'm just sort of drawing lines. So this looks like 19 and this looks like 10. So we do x and then the y number. So for all other points, write down the type of correlation. Well, the correlation just refers to sort of the pattern of the data. So as we can see, the correlation is just a positive correlation. And the reason I say positive is when one of the variables goes up like this, then the other variable also goes up, and that's how we see sort of the graph going up in this direction. So that's the answer to that, positive. Okay, so on the same day in another town, the max temp was 16.4. Estimate the number of hours of sunshine in this town on this day. Well, what you do is you roughly try and draw a straight line or a line of best fit through the data, something like this. And then what you do is, using what you have, you then see whereabouts it lies. So 16.4, right? So So what we do is we go to 16.4 on our graph roughly. So what does each one go up? So if this is 17, then there's sort of 5 spaces. So then each one goes up in 0.2. So 16.4 would be like the second point. So let's draw that here. So 16.4, somewhere like here. See where it hits our line, and then sort of draw down like this. And as we see, that's roughly 12.8. So we get 12.8 as our answer. So now the weatherman says temperatures are higher on days where there is more sunshine. Well, let's see. So as we see, the more sunshine there is, the higher the temperature, right, for our data. So what we can say is the answer is yes. It does support it. This statement. Since the majority of points have a greater temperature when sunshine is more. And this basically just goes to the idea of positive correlation. So this is basically just what positive correlation, which is what we figured out, that's what it means. Cool. Okay, so express 56 as the product of its prime factors. So we can write 56. We sort of break it up using our prime factor tree. So 56 can be, what is it, 8 times 7? And then 8 can be, I'll do it 4 times 4, which can be 2, 2, and then this can be 2 and 2. And then we've got all our prime factors here. So the 7, 2, 2, 2, and 2. So writing it down, so 56 can be written as 2 times 2 times 2 times 2 times 7. Okay. Okay. Oh, sorry. Over here, accidentally made a mistake. This would be 2, right? And so we'd have it there, circle that there. So we'd have 1 less 2. And another way of writing this is 2 to the power 3 times 7. Again, just combining all those 2's. Okay, next one, what I like to do is when we're doing this, I like moving the decimal points out. So this is the same as 546 times 43, moved 2 dp total in both numbers. So I just have to keep track. And then I reinsert the decimals back in. So if you do this, sort of lay it out like this. 3 times 6 is 18. 4 times 3 is 12, plus 1 is 13. 5 times 3 is 15, plus 1, that's 16. New line, add a 0. 4 times 6 is 24. 4 times 4 is 16, plus 2 is 18. And then 4 times 5 is 20, plus 1 is 21. So now we could just sort of add our results. So you get 8, 0 plus 8 is 8. 4 plus 3 is 7. 8 plus 6 would give us 14. So I'll put down the 4, remainder 1. So then 1 plus 1 plus 1 gives you 3, and then a 2. And now we've got our number, we insert the decimal points back. So we moved 1 space to get to here, and 1 space to get to here. So in total, we need to move 2 spaces back. 1, 2. So it goes there. Oh, sorry, and I'll write that. So our number is 234.78. Okay. Okay, next one, it says the area of the square is 10 centimeters squared. So again, when they tell you stuff like this, it's usually useful. So think about areas, so areas of squares, and we need to show that. Well, if this square has that area, then remember the area of a square is sort of this side times this side of the square, or the sides times together. Square is such that all sides are the same. So area of a square would sort of be the length of the square times the length, because again all sides are the same. So in our case, the length of this side is a 3 plus an x, because this bit's 3 and then this bit's x, so in total it's 3x. And in total, so it's like a 3 plus x times a 3 plus x. Or you could have just done it as sort of length squared, which you could have just written as 3 plus x all squared, like this. And so what we can do is we can multiply this out. So if you do that, 3 times 3 is 9, 3x plus another 3x gives you a 6x, and then x times x is x squared. Right, so that's sort of the area of the square from that. And we know that the area of the square is 10, so that's from the information. Therefore, using fact, we know that x squared plus 6x plus 9 would be equal to 10. Moving the 9 over to the other side, we get x squared plus 6x equals 1, which is sort of what we're asked to show. That's it. Okay, next one, we have a rectangular frame. It's made from 5 straight pieces of metal, and we know that the weight of metal is 1.5 kg per meter. Work out the total weight of the metal frame. Well, notice we have sort of a rectangle like this. We have it like this. Well, we can fill out all the information. So we have 12, 5. Since this is a right angle triangle, the length of this side would be 12 squared plus 5 squared all square rooted from Pythagoras. So using Pythagoras, and then of course since it's a rectangle, this one will be 5, this one will be 12. So what we can say is total length of the frame can be given as 5 plus 5 plus 12 plus 12 plus this square root thing. So let's figure out what this square root thing is. So we have 10 plus 24 plus, now the 12 squared is 144, 5 squared is 25, so when we add them together we get 25, and we're adding 144. So if we do that, we get 1 square root of 169. And then if you know from your sort of times tables that the square root of 169 is 13. And again, when you square root, you get plus or minus. I'm just going to take the plus because again, we're dealing with the lengths and therefore we don't really need to consider the negative square root. It doesn't make much sense. So if we do that, total length of the frame would be, again, 23 plus 24, which would be 4 plus 3 is 7, so that's 47, and again, that the units would be meters. So if the total length of the frame is 47, therefore what we can say is total weight of frame, so total weight of frame, well, the total weight would just be the total length times by the weight per meter. And so we have 1.5 kg per meter, and we have 47 of them. So the total weight would be 1.5 times by 47. Let's do that. And if we do that, 1 times 40 is 40. And so then 0.5 or half times 47, what would that be? That would be 23.5. So then 47 plus 23.5 would give you 70.5. And again, the units of the weight has to be in kilograms because that's what the fact was given in. Okay, good. Okay, last few questions. We've got two lines. Show that these two lines are parallel. So this is important. So the important fact is if two lines are parallel, then they have the same gradient. So that is a very important fact. So if we calculate the gradient of these two lines, so the first one, L1, is this, which means gradient M is 3. This is your gradient. And then line L2 is 3y minus 9x plus 5. Now this is not in the form of y equals mx plus c where we could read the gradient. So firstly we could rearrange. So we get 3y equals 9x minus 5. And then y is equal to dividing by 3 on all sides. We get this. And so what we get is that m also equals 3, which is the gradient. And then what we can say is since they have the same gradient, they are parallel. Okay, great. Now the last question is a vectors question. So we've got a parallelogram. Find in terms of b the vector db. What I think is, how do you get from d to b? Well, you can go this way, or you can go this way, you can go this way, you can go this way. There's loads of different ways basically that you can travel, but we need to know a path to get from d to b. Now just adding on to our diagram, this is b still, and this would have to be a, just because of the symmetry of the graph. So dB, well, we can just go straight from here to here. So dB, you can go from D to O, and then from O to B. And if you do that, D to O is just the B, right? Just this bit. And then O to B is also just a B, right? So it's just this bit. So in total, you have two B's. So the answer is 2B. Find in terms of A and B, the vector AB. Well, to go from A to B, can you see how to go from A to B? We can go this way and then this way, seems the easiest. So we can go from A to O and then from O to B. And if we do that, A to O would be minus A because it's in the opposite direction of A, right? A is this way, we're going in the opposite, which is this way. So that's that. And then O to B is just, well, B by looking at the graph. So making this look nicer, we have B minus A. Again, the order didn't really matter, as long as you maintain the signs. So now A to D, we could do this. So to go from A to D, which is here to here, we can go here and then here, which seems fine. So we can go from A to O again, and then from O to D. So A to O is again minus A, we did that before. And then O to D again would have to be a minus B because again we're going in the opposite direction of the B arrow. Alright, so I'll just write that as minus A minus B. Minus A minus B. Okay, so that's it. That's the end of this paper. So hopefully this was useful to you. Again, if you found this useful or you have any questions on improvements or anything you'd like me to do, I am going to be going through other GCSE videos, especially in maths and physics, so stay tuned for those. But otherwise, I'll see you in the next video. Thank you.